So I wanted to do a little bit about logarithmic functions and how they tie into exponential. So I kind of alluded to this in the last video, but if you didn't have a chance to watch that one and you wanted to do this one, I'm going to start off with that. So if we had an exponential like 2 to the second, which is 4, and 2 to the third, which is 8, if I wanted to know what 2 to the x is equal to 6 is, the only way I can solve for that x is to change this to a logarithm. And you have a log, and what a logarithm always gives you is the exponent, or this x that's in the exponent. So you take the little subscript, the 6, and it will give you what x is. So when I evaluate this logarithm, how I have to do it is either log of 6 over log of 2. That's probably the easiest way. And on your calculator, you will have a log 6 and a log 2. And when you type it into, especially like a Texas Instrument calculator, make sure you close this parenthesis, divide by log of 2. It doesn't matter if you close the second one, but the first one you definitely have to close. And when you get that, you get x is equal to 2.58 approximately. And this number right here would be the exponent that gives us, if we say 2.58 up there in the exponent, we'd get something close to 6. So I kind of alluded to this in the last video, but like I said, not everybody probably was watching that because they were okay with some of those things. I do suggest maybe watching it. It's okay. It's up to you. But logarithmic notation is really not that hard. These two things are the same statement. The b, this b, is the base of an exponential. And logarithm always gives us the exponent, and x always gives us what the exponential gives us. So like 2 to the third is 8. 8 is the x value. This is the x value. There you go, x value. And b is the 2, and y is the 3. So it's just rearranging things and then being able to evaluate it. I always say, if you're not sure what to do when you have a logarithm, change it to an exponential and see what you have. If you have an exponential and you're not sure what to do with it, change it to a logarithm and see what you have. And that's always just a rule of thumb. Now, if I had log base b of x, I'm sorry, I didn't want to do that. If I had y is equal to bx, I'm sorry, and I wanted to find the inverse. Inverse is you switch the x and y, and you solve for y. Well, the only way you can solve this for y is to change it to a logarithm. So what a logarithm always gives you is y is equal to log, the little subscript is your base, and what it equals is x. If I was to graph this, it looks like that. And you notice that along this dotted line right here, or this blue line, I should say, this blue line, if we folded it on that blue line, the green would fold onto the red. So inverses always do this. And so what a logarithm is just the inverse of an exponential. The exponential, you switch x and y. And because this is not a correct form here, you have to change it to a logarithm to make it a function, so it's equal to y. So that's what this is about. I didn't want to do that. I'm just going to do this. Most common logs are, if I just have a log, they're base 10. So if I just say log, it's usually going to be abbreviated as base 10. So we don't write that little subscript 10 when we're talking about it. And on our calculators, if we look for a log button on our calculators, that log button is base 10. So if I was to evaluate log base 10 of 1, we would get 0. If I took log base 10 of 10, it would be 1. And log of 100 would be 2. And log of 1,000 would be 3. And you might say, well, that's the number of zeros that you have. You have 0. I have no zeros here. I have 1 0 here, 2 zeros here. And then you could think of it that way. But in reality, when we have a problem like this, let me erase those. If I had log of 100, and we know that's 2, this is base 10, so it's 10 to the second power, which is 100. 10 times 10 is 100. So rearranging these are equivalent. You can see why that log base 10 of 100 is 2. But just to keep in mind, you can evaluate log of 1,000 to say it's 3. Now with E, sometimes we have E, and that's this natural log. And it looks like a 1n. It's really ln with a lowercase l. And it means natural log, and its base is E. So this log base E of 1 is not written that way. We write it natural log of 1. And log base E of 3, you would write that natural log of 3. And you usually have a natural log key. It looks like this on your calculator. And you might think it was 1n, and it means ln, because it's really confusing. But all you would do is, if I was going to try to figure this out, which I know is going to be 0, because e to the 0 power is 1. Anything to the 0 power is 1. But if I'm going to type it in my calculator, I'm going to type this ln and then 1 and then equals button. That's usually the way you would do it. Now, if you're doing a cell phone, and I really don't suggest it, I'd rather you use a screen calculator just to make sure you get these right. You would push 1 and then the ln key, and it would give you 0. And of course, the answer would give you 0. And one that you really need to know is just memorize this. Ln of 1 is 0. Ln of E is 1. And the reason why is log base E of E is 1 would be E to the first power is equal to E. Well, anything to the first power is E. So what they do with you is they have you rearrange these, and they want you to write them as logs. So this is log base 8 of 64 is 2. Remember, a logarithm always gives you the exponent. So I know that this one needs to be equal to 0. And it's natural log of 1. So you're just rearranging the letters. If you wanted to write it like this, just so you know where everything is, then rewrite it this way, that's perfect. So this is going to be log base 7, little subscript, 343 is equal to 3. This would be log base 2 of square root of 2 is 1/2. Remember, everything is going to equal the exponent. So this is going to equal 2. This one's going to equal 0. This is going to equal 3t. So whenever it's natural log, or it's Euler's number E, it's going to be natural log of 1. And this one would be log base 5 of 25. This would be natural log of 8 is 3t. And this would be log base 2 of 16 is 4. And so sometimes they want you to go the other way. So changing the logarithm to an exponential. So 10 to the 0 is 1. Well, we know that's true. We know that 2 to the 5th is 32. So rearranging this stuff. Oh, wait a second. No, this is ln of u is s. Well, remember, this is base E. So E to the S is U. E, this would usually be written ln, but I wrote it this way. E to the 1/2 is equal to the square root of E. 10 to the second is 100. 3 to the 4th is 81. So being able to change these from exponential to logarithm, especially when we have variables in them, is really important. So that's why we practice this. So how do you find a logarithmic equation without a calculator? Well, I don't know. I mean, I do know, and I'm going to show you. But you could just do this, just take log of 16 over log of 2, and you get your answer. But we don't want to do that on the calculator. We can, but anyway. So what we're going to do is we're going to say 2 to, I don't know, we're going to say this is x is equal to 16. Then we're going to make our bases the same. So we get 2 to the 4th, because 2 times 2 times 2 times 2 is 16. And now you have the same base, so you can say x is 4, because that's what it needs to be. And you might be able to just see it right here. Oh, x has to be 4, because it has to be multiplied 4 times to get 16. On this one, it'd be 5 to the x power is equal to 125. And 5 times 5 is 25. 25 times 5 is 125. So that would just be 3. So kind of showing you why you have them. It's telling you what the exponent is. Logarithms always give you exponents. So 2 to the x power is equal to 64. Now 64 is not a normal number that we use all the time, but it would be 2 to the 6th. 2 times 2 times 2 times 2 times 2 times 2, which would be 6. So the answer is 6. This is 10 to the x power is equal to 100. Well, 100 is 10 times 10, which is 10 squared. And so we get 10, x is equaling 2. Now, when they get to be harder, this is when I would suggest maybe going to that calculator and getting the answer. But I want to show you that you can do these by hand. 2 to the x, I don't know what that is equal to 1/4. Now, we're going to have to manipulate the 1/4. It's 2 to the 2nd. We need to make our bases the same. So I take this and throw it upstairs. 2 to the 2nd power becomes -2, because when you take something up into the numerator, it becomes a negative by the negative exponent rule. And now our bases are the same. You notice the 2's are the same. So now what we have is just x is equal to -2. And then on this one, it's base 10, because that's what we're trying to figure. If it doesn't have it there, remember it's 10. 10 to the x is equal to 0.001. Well, how do you say this? This is 1,000th. Sorry, I spelled that wrong. 1,000th with the th at the end. So that's 1 over 1,000th. And 10 to the x is equal to 1 over 10 to the 3rd. Throw that upstairs and you get x is to the -3. But if you throw this into the calculator, say log button and then 0.001, you get -3. Oh, -3. And these are the ones that I was saying that you just need to know. This is 0. This is 1. Natural log of b is 1. Natural log of 1 is 0. You can prove it, but it's just one of those things that you just know. 5 to the x power. Logarithm always gives you x, or the x value. 5 to the is equal to, I'm writing too fast for the computer, 5 to the 4th power. Now the bases are the same, so we just say x is 4. So that means if I have this one, let me write, remember when you have a 4th root, you can write that as to the 1/4 power. So that's what I'm doing. And I'm going to say 3 to the x is equal to 3 to the 1/4. So this would be x is equal to 1/4. But on each one of these, and these get a little harder to do, but let me do it here. I could write this log of the fourth root of 3 all over log of 3 on your calculator. And that's a little hard to do, but it'll give you a fourth if you get it down. And it'll easy questions when it comes to those, if you know how to use your calculator right. Now, this change of base theorem, I alluded to it before, is if I want to evaluate this, I just take log of 5 over log of 2. And when I do that, right here, I get 2.322. Now, if I wanted to do the same problem but use natural log, I'd still get 2.322. So it doesn't mean that you have to put log of 5 over log of 2. You can put natural log of 5 over natural log of 2, and it's still going to give you the same answer. So the previous one was this one. Notice, look right here. And look at this one. And both of them, you notice you get 2.322. So when you do these, you're just using the change of base. I'm not sure if you have one like this, but I bet you do, because almost every college algebra class has them. It's one of the applications of this, and it gets scary, and you're like, whoa, pH, like soil, you either have a acidic soil or you have alkaline soil. Alkaline soil has like white stuff on it. Acidic soil is hard to grow stuff in, and it's usually like with pine needles in it and things like that. The best is kind of a neutral, and then it grows better. Plants grow better. So the formula, I'm going to write it this way. Now this is hydronium ion. This is just a number. It's just like a variable. That's all you're going to put in there. And it's going to tell you the pH of this. So once you just put negative log of that, you get the pH of the soil or whatever you're talking. Sometimes you use litmus paper in chemistry. So this is in scientific notation, and it's the hydronium ion. And all we're going to do is put it in here. And if you wanted to, you can move the decimal points 0.00025. Plug that in there, and take negative log of that number. And I would alleviate all this mess, and you would get 3.6. Now, if you know how to type 2.5, usually on a calculator, it's called the EE button. You push that EE button, and then you put a minus and then a 4 in. And so if you type in negative and then log, so the log button, and then 2.5 and EE and negative 4. Sometimes calculators have a times 10 button, or sometimes you can just type it in times 10 raised to the negative 4. So this depends on which calculator, all different ones. So let me clear this off. A little messy. So that one's just plugging it in and get the answer. This one's more of an equation. So it's telling us what the pH is. So we're going to put 7.1 in, negative log of, I'm just going to call it X instead of this H3O plus the hydronium ion. So what I need to do is I need to divide by negative 1. I'll get negative 7.1 is equal to log of X. And that's what I'm doing right here. And change this to a logarithm, or change it to an exponential, I'm sorry. So it's base 10, we just don't write it. 10 to the negative 7.1 is what the exponent is equal to X. And then you just evaluate that on your calculator, and you get 7.9 times 10 to the negative 8. And that is the concentration of the hydronium ion. So that's an application. Most textbooks have a question like that. So on to properties of logarithms. So there's all kinds of properties of logarithms, and I'm going to write them down on the next page here. There's lots of them. So I always had a card, and I wrote down all the log properties on that card. Like I said, there's tons of them. So the first is just that, the one where we change it from logarithms to exponentials. So b to the y is equal to x. So b raised to the y power is equal to x. So that's one. And then, like I said, there's lots of them. So we have the change of base theorem, which is log of x over log of b, or natural log of x over natural log of b. Either one will work. This is the change of base. That's when you want to do something that's not base e or base 10. But what we'll go into is this idea if you have log base b of x plus log base b of y, you can write the log as one logarithm by multiplying both x times y. And you can go either way. So if it's multiplication, you can write it as addition. If it's addition, you can write it as multiplication. If it's subtraction and the bases are the same, you divide them and vice versa. So x divided by y. So you can write that log base b of x minus log base b of y, going backwards if you wanted to. So we call this the addition. Sometimes it's called the multiplication. This one I call subtraction rule, but it could be also called the quotient rule because it's division. Then you also know that natural log of e is 1. Natural log of 1 is 0. Now there's another one here that I want to have, and it's if you have log base b of b, it's always going to be 1. So if I had log of 3 over 3 to log base 3 of 3, it's 1. Log base 4 of 4 is 1. Log base smiley face of smiley face is 1. It doesn't matter. As long as those two things are the same, it's always going to be 1. And then we have what we call exponent rule. So let's say we have a log with x to the nth power. What we can do is we can throw that n in front, and we'll get n log base b of x. So it's just like throwing that n in front and then writing it so you don't have an exponent. And that's a really important rule to calculus as you move on into upper level classes. Other ones, it's not so big a deal. And then there's also one that looks like this, b to the log. So we have a b, a base, and then we're raising it to a log with that same base of x. And if you do this, these cancel. So I call these the exponent rules right here. I'm not being really mathematical with you, but I think if you remember, if it has exponents, I remember Mr. Beal saying something about those. So I'm going to clear those off, and here's the product. You see, they call it the product rule, and sometimes they call it an addition rule. If the bases are the same, you can write them as a multiplication problem. So 50 times 2 is 100. And we know from previous, just earlier on, that that would be 2. So on this one, I already have the answer, sorry about that. It's the quotient rule. And it means that if you have them subtraction, you can divide the two and get 8. And then remember back that if you have this rule, log base b of b is 1. So if these two things are the same, it's always going to be 1. And then this has the exponent rule where we are going to throw the 4 in front. So I throw the 4 in front, and then I have 4 log base 3 of 3. Log base 3 of 3 is 1. 4 times 1 is 4. So these are with really nice ones. Sometimes you have to use your calculator to get the answer. And this one often comes about a square root of 6 could be written as 6 to the 1/2 power. Throw that 1/2 in front. And now log of 6 base 6, log base 6 of 6 is just 1 times 1/2, which would be 1/2. And then that last rule that I was bringing up, and I guess they call it the inverse rule, but I call it the exponent rule because 2 raised to a log of 2, these cancel out, and I'm just left with 5. So these cancel out, you just get 8. And we're going to use that exponential rule right here later when we're solving equations in the next, solving logarithmic equations in the next section. But the most important thing you have to learn how to do is this systematic, is you need to expand logs, and then on the next slide, decompose the log. So here we're going to expand it, and then on the next slide, we're going to, well, next slide's over, we're going to bring it back. And we have to use all these rules that we have. So you see multiplication here, and you see division. So what you see in red or blue there, division is fraction, and then multiplication. So what I'm going to do is I'm going to write log base 8 of x plus log base a of y to the 5th. And then the division means subtraction. So minus log base a of z to the 4th. And we think we're done. We type all that into into MyMathLab, and it doesn't like it. What we have to still do is bring down the 2 with the exponent rule, bring down the 5, and bring down the 4. And this is being decomposed. We decompose this logarithm into a long log. So sometimes you have to do it the other way. So we have to go backwards. And it takes a little bit of practice, and you might have to do a few to kind of get it down. But once you get it down, it's not too bad. So on this one, it's decomposing again. I'm going to put a to the 2nd b over c to the 5th, and I'm raising this to the 1/3 power because remember, square roots is x to the 1/2 power. Cube roots are x to the 1/3 power. Fourth roots are x to the 1/4 power. So that's what I did, was I made this cube root b to the 3rd power. And now I'm going to throw that in front. Now, when we throw it in front, we got to be careful because we're going to decompose this. This is division. This is multiplication. Or multiplication, I'm sorry. And then this is division. So we have to distribute that 1/3, clear through all this. So I'm going to have log of a to the 2nd plus log of b. Yeah. And then subtract log base, log of, I'm sorry, c to the 5th. The bases are just base 10, so that's nice. So we have that. And then keep this 1/3 in front. And you might have to play around with it and really take note what MyMathLab accepts with your answers. So What I did was bring the 5 down and the 2 down. That's all I did with those. The b I didn't have to do anything with. And now I can either write it 1/3 like all this, or I can write 2 log base a plus log base b minus 5 log of c. And if you get a problem where you're not sure, you get it wrong and you're like, I thought that was right, let me know so I can go back into your homework and count it correct, because a lot of the times it just doesn't accept all the different answers that you can get with these decomposing of logarithms. So this is the other way. It's saying express it as a single. So this is, we're going to compress it now. We decompressed it, or decompressed it. We decomposed it. Now we're going to compose it. So what we want to do is take this upstairs. So we have log base a of x to the 2/5 minus log base a of y to the 1/3. And that's an a. It's a pretty bad a. And because we're trying to combine this, we want to go ahead and write it log base a of x to the 2/5 all over y to the 1/3. And depending, because this is subtraction, so it's division, and depending, if they don't accept this answer, then you got to go further with it. So log base a of the 5th root of x to the 2nd all over the cube root of y. And one of these two answers should work in it. And it just, again, depends on how far they want you to go with it. So hopefully this helps. Let me do trying to clear that. Let me do a little bit easier one where we are writing it as 1. Let me see, this is 3 and this is 3. Y, yeah, y. Okay, so, and then minus 4 log base 3 of z. So what we would do is we'd bring the 2 up. We get log base 3 of x to the 2nd plus log base 3 of y to the 3rd minus log base 3 of z to the 4th. And plus means multiplication, so it's going to be log base 3. These are all the same bases. If they're not the same bases, you can't do it. Log base x, and they try to trick you sometimes with that, just a warning, divided by z to the 4th. And that is in compressed form as a single logarithm. And that should help you get through some of the other homework. And then what I'm going to do next with the next video is actually how do we solve equations that have logarithms, or how do I solve equations that are exponential? And that should help you also.